Hi there. Here's a lesson on the distributive property. It may be a review, may be new to you, but take it all in. Make sure you understand what it is, and let's focus on this learning target for today, or our objective. I like to make my target because it's a learning target. We're trying to get there. All right, that's what we're shooting for. To use the distributive property to simplify expressions. So I really want you to know what the distributive property is and how it can be used, or how it is used. We got a couple key vocabulary terms we'll get to. The distributive property, what a term is, constant, coefficient, and like terms. Things that you should have learned before, but if not, well, take it all in. Um, so let's actually skip to this. Let's jump around. This has a whole bunch of stuff on here, um, but we just want to focus on what the key terms are, the vocabulary. So a term, that was one of our words. A term is a number, a variable, or a product of a number or variable. So terms are like these right here. Could be 7a, negative 3a, and those are actually terms that are alike. What do we got? It's 4x squared, so it's got a variable, it's got a number. It could just be, I'll add a couple other ones. It could just be y, it could just be 6. Those are also terms. They're just a number or a variable or a combination of the two. So that's term we said we are going to do. Constant we'll do next. A constant is a term that has no variable. So really it's just a number. And I'm going to put that here. A number. When you see a number in an equation or expression, kind of like right here. Well, actually, technically that'd be negative 12, but that is a constant. It's just a number. It's not going to change. You can't change a number. You can't have different values for that number. That number is what it is, so it's constant. Next term, a coefficient. Oops. A coefficient is a numerical factor of a term, meaning, now I'm going to put this in simpler terms, it's the number in front of a variable. Come on, stay there. Whoops. Of a variable. So if we're looking at like this one, 7a, the coefficient is 7. Co, if you look at the prefix co, that means with. So it's with the variable. The coefficient is with the variable. This would be a negative 3. Negative 2 is the coefficient here. There's none here. 6 would be the coefficient here. All right, so you get the point. It's the number in front of the variable. You might want to make note of that's the normal person's definition. Next one is what like terms are. Like terms we've done before. We definitely did in the last chapter, but remember, like terms have to have the same variables. So 7a and negative 3a both have a as a variable. So yes, they're like terms. 4x squared and 12x squared, yes, they're like terms. X squared is the variable term. 6ab and negative 2a. This one's tricky because they both have a, but for them to be like terms, they have to have the exact same variables. This has an a and a b, this one just has an a, so no, they are not. And then xy squared and x squared y. Again, they both have an x and a y, but each variable, the same variable has to be squared on both of them. So no, these are not like terms. That's just a good review for us, but we're going to actually go on and talk about what the distributive property is. So let's go through a couple situations here. First of all, the ice cream date. All right, classic. Katie and Joe go on a date. They see some delicious ice cream at Uncle Harry's, but both want the same flavor. How can they both have the same flavor? Well, duh, distribute some to each of them. All right, that's where that word distribute comes in. So here's my visual. You got your ice cream at Uncle Harry's. You got Katie, and you've got Joe. And they both want ice cream. Well, give it to both of them. Give them some of each. So the ice cream goes to Katie, and the ice cream goes to Joe. And now they both have the same ice cream. Believe it or not, that's what the distributive property is. It's taking something and giving it to both of the things you want to give it to. So the ice cream goes to Katie and Joe. Well, Katie has ice cream and Joe has ice cream now. We're going to do it with numbers in a second, but we're going to do this next one. Um, Believe it or not, you may use it in mental math. You might have learned this a long time ago. It says you need to figure out what 3 times 23 is in your head. Since you don't have a calculator and your phone accidentally dropped in the toilet, how could you use mental math to figure it out without trying to count? Well, answer is, let's break up 23 into smaller, easier numbers to multiply 3 by, and then distribute 3 to both of those numbers. So I'll write it out for you. I'll model it for you here. You've got 3 times 23. Okay? Now, you can break up 23 into some numbers that are easier. I'm going to break it up into 20 and 3, because that makes 23, right? So that's inside of the parentheses instead of the 23. Now, all you're doing is multiplying the 3 by the 20, and the 3 by the 3. And maybe you can do those easier in your head. I know I can. That's why I do this. So 3 times 20 is 60. Oh, I forgot this part. 3 times 3. 60. And 3 times 3 is 9. So you end up getting 69 as your answer. Okay? It's an easier way to break it up into smaller chunks. That's using the distributive property. We distributed the 3 to 2 different things instead of just to the 123, to the 20 and to the 3, and you end up getting that. And that is correct. You can write it out 23 times 3. If you write it out this way, the old classic multiplication, 3 times 3 is 9, 2 times 3 is 6, and there's another way to do it as well. Okay? But anyway, let's formally look at what it is. The distributive property, where A, B, and C are all numbers. Here's the algebra version, which is all letters here. A, when you multiply A times the quantity B plus C, that's the same as distributing the A to both the B and the C, and you get A times B plus A times C. Oh, I'm sorry. It's really important to keep the same symbol between them. If it's addition in here, you keep addition. So here's the second one. Well, this is the same thing. It's just the A is on the other side. You're still distributing it to the C and to the B. So B times A plus B times, or C times A. Now, with subtraction, it works as well. I usually would say change everything to addition and adding the opposite, but subtraction works as well. You're keeping that same subtraction sign between them, and you're just distributing the A times the B and the A times the C, and that's where you get these. All right, and here's some examples with numbers. But I want to go through a couple of examples with you. I'd advise trying them on your own first and seeing how you do, but definitely follow along for how we do this. So this is your classic example of using the distributive property right here. 3 times x plus 8. So we said we need to give 3 to both the x and the 8. It's like 3 is the ice cream and x and 8 are the Katie and Joe. So we're going to distribute the ice cream to both of them. We're going to give that 3 to the x, and we're going to give the 3 to the 8. And since it's always multiplication when you're distributing, it's got to be multiplication out in here. So we're distributing that 3 times the x and the 3 times the 8. And you keep that symbol in between. And you might know off the top of your head that 3 times 8 is 24. So right there, we distributed, and we got this as our simplified answer. We're going to do the same thing with letter B, only the number is in the back. That's okay. So here's what I'm going to do. I guess we'll leave it with subtraction. I prefer to change. We're going to do this. We're going to change addition to adding the negative. So now I'm going to distribute negative 7 to the 5b, which is negative 7 times 5b. Keep our plus sign because we changed it to a plus. And now do negative 7 times negative 4. Why does it move on me? I tell you. All right, times negative 4. And negative 7 times 5 is negative 35. So we get negative 35b. Oops. And then negative 7 times negative 4 is 28. So we get negative 35b plus 28. All right, why don't you try one or two of these on your own? I've got 3 here. And at the end, I'll show you the answers to those. All right. there is one exception to the rule, and this is using distributive property with division. It says, what is the sum or difference of that's equivalent to this? It doesn't look like there's any parentheses or anything, but really it's one big thing divided by 5. So you do distribute the dividing by 5 to both of those. And I want you to picture it like this, doing like a heart here. You distribute it there, 7x divided by 5 there, and then the 2 divided by the 5, and you keep the addition symbol in between. So really it's like 7x over 5 plus 2 over 5, which is shown right there. Now this is a different way to do it, so I'm not showing you that way. But you get the same answer here. If you want to look at this work, this is slightly different. When you divide by 5, that's the same thing as multiplying by 1/5. But you get the same answer right here. 7/5 x plus 2/5. So I'd like you to try one of those as well, based on what you just saw there. And I'll show you your answers at the end. And then I have one more situation that might be given. And this actually is dealing with negatives. So what happens when you have just a negative out in front? Well, we're doing the same thing. We're going to distribute the negative. Change this to plus a -3. But we're going to distribute the negative there and to there. So you have negative in front of the 2y. Keep the plus sign. You have negative 3x. And you know what happens when you have minus a negative or two negatives right next to each other? They become a plus. So the answer should be negative 2y plus 3x, which is right here. And I hope that's correct. If that's not correct, then I'm going to be upset. But there you go. There's your answer. So why don't you try at least one of those as well, and you can pause it, and I will show you the answers at the end, which is actually going to be in just a sec. Alrighty, so if you're looking at the first part, here's your answers. A would be 5x plus 35. B would be 36 plus negative 2x. We're distributing everything here. C is 1.2 plus 3.3c. And then D would be negative 2y squared plus the 1y. Make sure when you have minus and negative, you cancel those out to become a plus. Section 2 with the division. We have 4 over 3x minus 16 over 3, or plus the negative 16 over 3. 11 over 6 plus 3 over 6x, which reduces to 1/2 x. C, we have 5/4 plus 1/2 x. Again, I'm just reducing the fractions. 15 over 12 would reduce to 5/4. And 6 over 12 would reduce to 1/2. And then D is 1/2 minus 1/4 x, or plus negative 1/4 x. Finally, last section, you get negative a, that's an a, not a 9, plus negative 5. B is positive x plus negative 31. C is negative 4x plus 12. And D is negative 6m plus 9n. All right, and that is pretty much a good chunk of examples that you'll need to know how to do the distributive property. So let's look back at our goal, which originally was to use the distributive property to simplify expressions, and we certainly did that with many expressions. So I hope you got something out of this lesson. If you have questions, make sure you ask your teacher as soon as possible. Have a great rest of your day. Bye.